Today I will be demonstrating Project 4 I/O devices. Starting with my code, I used the U-input tutorial provided in the document to create this emit function, which makes it easier when I start to create events and emit them. Then, in my main, I begin with setting up libUSB, as explained in the tutorial provided in the document for libUSB, the first link. I change these two parameters to match the decimal versions of the vendor and product IDs that are provided in hex in the document, and I change the size of my data array. For the purpose of this project, you only need data at 0, so you could set the data array to a size 1. And I start creating U-input and open it up, and here's where I set the events. I set the event bit for the keys, and we only need a button, so this sets the button event. And then I set the events for the ABS, which includes the x-axis and the y-axis. Following the tutorial, I continue to set it up using the vendor ID and product ID provided, and create a joystick called Daniel's Joystick, named after me, and continue on to actually loop through and collect the data. I create a boolean that is true until the Chomp app exits, in which case it becomes false and exits out. I have my 3 integers, button, x, and y. That's all you need. And I use bit shifting to get the bits necessary to read the data. For button, I shift it over 4 times, and I collect that bit, which is either a 1 or a 0. For y, I collect the last 2 bits. And for x, I shift it over 2 times, so it is at the end, and I repeat what I did for y. Then I have a bunch of if statements and else if statements to read through the data to see what to collect and what to omit. If the button is 1, I use the key event and the button start, and I pass in 1. If it is 0, I pass in 0, and then I report the event as seen here. If y equals 1, I do the same thing, except it's an ABS event, and I use the y-axis, and I pass in 32,767, 0 if it's 2, and negative 32,767 if it's 3, as explained in the document. If y should be 0, I pass in nan, because it is an invalid number. I do the same for x, as you can see here. Else, the loop is false, I release the interface, and I close libUSB and exit. Then, all that remains is to delete the data to deallocate the memory. I destroy the U-input device, and I close it. And that is pretty much it for the code. Now I'll demonstrate how exactly it all works. You open up Chomp app. This is your virtual driver. The raw state is the data that you're collecting in hexadecimal, and that's where you're pulling everything from. And you see the different y and x states here. Now, once you open, you want to connect the USB device and run your code. And now my code is looping, as you can see. Finally, I open up JS test within the dev input library, and this is all the data. As you can see, it recognizes that I have 2 axes and a button. Now, if I press the button, it is now on. If I turn it off, it's off. If y is up, it's negative 32,767 as provided in the document. Down is positive. X left is positive. Right is negative. And this is the data that will communicate with whatever you're using your joystick for, making it a working driver. And that's it. Thank you so much for watching.